All right, everybody, here's a little problem for you guys to work on. I actually think it's question 15 from your homework set.
Can you still hear me?
I can still hear you, yes.
Okay, I'm just making sure because it's gave me something. Yeah, it's good.
Oh, yeah, I have a problem with this.
It's actually been written on the board for a little while, so maybe we can start doing it. What is the derivative here? How do I take the derivative? Who actually watched the videos? What is r prime of t or dr dt?
Two cosine t 0 minus 2 sine t.
Okay, that looks good to me. Is everyone good with that?
Yeah.
All right, so now it says, let's sketch it. We're sketching r of t, and then we'll look at the tangent vector at t naught. So what is the sketch of this thing? What does it look like? I need more black pens, apparently. Well, we know we're working in the y equals 1 plane, right? That's not changing. So if you're not sure what it looks like, just do a couple points. And since we're doing trig functions, we're looking at angles. Maybe we'll use values that are useful or easy to plot in terms of angles. So sine is 0, sine of pi over 2 is 1, so this would be 2. Sine of pi is 0, sine of 3 pi over 2 is -1. 2 cosine of 0 would be 2, and pi would be -2. So it looks like I need to add in some z components and some x components. But we're only really going out to 2, right?
Well,
All right, so at t equals 0, x equals 0, we're on the y-axis, but we're up 2. At pi over 2, x is 2, z is 0, so I want this point right here. At pi, 0, -2 is down here. And -2, 0 would be back here. So we were going like this, right? It's making a circle, isn't it? Okay. And at r prime of pi over 2, what do we, pi over 2 was this point right here. So that we're looking at this point right here. Where's the tangent vector there? We look at r prime of pi over 2. Cosine is 0. Y is 0. -2 for the Z component. It's just straight down. So that's R prime of pi over 2.
That's function.
And remember, these are points. This is RT is a position vector It's pointing to the point location along the curve. Am I off by something? I hear a lot of good chat.
Did you have a question? Yeah, we got a question. Oh, I'm like, am I just that blind that I cannot see you just raising your hand?
So what's up? What's the question?
No, nothing.
I got a question.
Nothing. Yeah, we got a question here though.
So this derivative of this vector equation have magnitude S2, right? So what that magnitude represent?
I got a question asking what would the magnitude of the derivative represent of a vector?
It's the magnitude is like how much it's changing. Because the tangent vector is representing what kind of change is happening at that point, right?
Yeah.
And it's representing the strength or magnitude of that change.
So on that circle, that possible every tangent line and every point, their magnitude is the same. Or it depends on the other, if changing another equation.
It should be.
Tangent
It
line.
should be 2 each time, no matter what we plug in on this, no matter where we're at.
Right.
Like if we do pi, we've got -2, 0, 0.
Still like that. Right now it's the, so changing another vector equation. That means it might be
So
different.
look at what's going on with the like let's look at the curve right here. It's going like this and it's changing like this. The curve is changing. So it was going like kind of flat here. It's curving up. It's really like how much of a change is going on if you're looking at the magnitude. At this point right here, that exact point right here, everything is in that X direction. We're slow, like right after pi, like maybe pi plus 0.01. We're going to have a Y component and, well, not a Y component. Y is out, Z component. We're going to have an upwards component, but right at there, it's not. Maybe we look at 3 pi over 4. Nope, let's do 5 pi over 4. Let me do that.
I do not have a negative.
So cosine of 5 pi over 4 is √2 over 2. That's just, and then multiply by 2 is 2. So just 2, 0. But it's negative. And 5 pi over 4 is also negative. It's also negative √2 over 2. The -2 is canceling out the -2. It's just positive √2 that, or positive Yeah,
Yeah,
put the root back in. So we got root 2/2, -0, root 2/2. This is at 5 pi over 4, which is right about here. Because this was 3 pi over 2, which is 6 pi over 4. That's 4 pi over 4 or pi. 6 pi over 4 is right there. So 5 pi over 4 is here. The tangent vector is doing -√2, so it's still going left some, but now it's going up at an angle sum, and the magnitude is 2. So the magnitude isn't changing. But it's representing how much of a change is going on in X and Z right there.
got it. Thank you.
Got it?
Yep.
All right, let's do something else. Find parametric equations of the tangent line at T naught. For R of T equals 2 cosine pi of T in the I hat plus 2 sine pi of T in the J hat and 3T in the K hat.
On the graph.
Give me 1 second. I just heard my dog screaming. Is he all right? Is he on the ground? Was he on the ground when you left? Okay, so he just bumped into something or scratched. Okay, he's still in class.
You're a sign. Just like a question.
Your signs have.
Mhm.
The first time I know it.
They're really.
No, I mean. C++ shouldn't be having this.
I mean, yeah, well, that's how just the notation of writing on videos. Zero. Time at zero. Time, initial time order. I was kind of confused why you did that. It's like you're using like T not and zero.
Well, first off, what's the derivative? What is dr dt?
2 pi sine of pi of t, I think. If I remember how to take derivatives.
2 pi sine of pi of t, is that what you said?
Yeah,
Shouldn't that be a negative?
the cosine will be in the. Wait,
No, you're thinking of sine.
It
If
is
sine goes
negative.
sine,
honestly, I don't remember how to take derivatives. I thought the other one was negative.
Plus,
But cosine
sine is
sine-
the derivative of sine is positive, the derivative of cosine is negative.
don't forget
I need a pi in there.
yeah.
Trying to talk and write at the same time clearly doesn't work.
Multitasking is a lie and you know it.
Right? All right, so what was being requested here?
the equation.
The pair,
the tangent
We
line.
want the equation. So we want an x equals y equals z equals. Those are our parametric equations. If I plug in t naught as pi over 3, I've got negative 2 pi sine of pi over 3. What is the sine of pi over 3? Please don't use your calculator. Please tell me you have your trig values memorized. What is it?
√3/2.
It's √3/2. So the 2's cancel, and I've got negative pi √3. I'm sorry, negative. Yeah,
That's
Negative
yeah, it's like a
pi.
positive.
what am I doing here? I'm doing something all wrong here. I know what I'm doing wrong here. We're doing parametric equations. We still need the initial position. So this, what we're doing here, this is not XYZ. This is the B vector. We still need R0 plus TV. B is going to be what's going on here. So what's R0? R0 is 2 cosine of pi over 3. Pi over 3. 2 sine of pi over 3. And 1. We still got that negative pi √3 because we're going to need that in a second. So this is 2 cosine pi over 3. Cosine pi, sine of pi over 3 was the root 3 over 2. Cosine pi over 3 is the 1/2. So cosine pi over 3 is 1/2 times 2 is 1. This is the root 3 over 2. Root 3 over
I
2
think
times 2 is
Did you forget to put the pies in for when you put in? Oh, no, wait. No, yeah.
you're right there. This is R naught, the original vector.
Oh, that's for the
Position-
original. Never mind.
R
Okay,
is a
that's for-
position vector.
Okay.
And then we got 1. So that's my R naught. My V, we're still following along this. Let's now continue. I got distracted. Someone was throwing me off. We did the -2 pi sine pi over sine pi of t. Now we're doing 2 pi cosine pi of t at the 1/3. Cosine pi of a third is the 1/2. So we've got 2 pi times 1/2 is just pi. And then we've got a 3. So this is plus t times negative pi over 3. Not sorry, negative pi root 3 pi and then 3. So our vector in that form is starting, it's at that position, 1, 3, 1, and it's going in that direction. We write it together as 1 minus pi root 3 t, root 3 plus pi t, and 1 plus 3t.
So I'm wondering for your notation, how come, like for the last line, you have R prime of T naught, and then, oh, never mind. Okay, never mind. In the video is you had, instead of dr dt, you put R prime of 0 for some reason. I didn't get that in the lecture video.
Yeah, r prime
you
at
did-
0 means r prime at t0. And t0 is, in this case, 1/3, not 0. Everybody with that?
Wait, so that R naught equals, why on the next line did you have the plus T? That's not until you actually do the initial value, right? And your derivative.
I'm finding the tangent line at t naught. So it's gotta start at the position of r naught because we're on whatever the graph is and it's going in a certain direction.
Right.
So like if it's here, it starts here, it's going in a certain direction. I need the r naught and
It's on the right. And then are we still in the right next line?
I shouldn't need the t in there.
Because I thought that was just evaluating for R, the original vector at, to find that point, right?
Yeah.
Or is
Yeah,
it a vector?
hold on a second. I'm confusing myself.
We have to write in that form.
Because shouldn't the last one say R naught plus TV equals all that?
Right there?
Yeah, like shouldn't that be what is in front of the last line?
Yeah, this is r naught plus t and v.
You'd probably be putting it into that, so. I think
Right,
the
okay.
Question will get answered since we're gonna be putting it into parametrics anyways. So whether that is different, but not.
Makes sense. I was just confused because it looked like it, that's
I'm not
just the R
completely
naught.
sure just
And
myself.
it's continued in that whole thing. is R
Yeah,
naught.
I did them in the wrong order. I'm sorry. So we needed r naught. It's here. We calculated it here.
Right.
Then we needed the v, and I had started doing the v first, which was silly. I just had in my head the tangent vector, but we need the position also. And so I rather than finishing the damn tangent vector, I rewound, which is not helpful when you're teaching. Quite fine when you're doing the problem yourself, but when you're teaching it, it's a shitty approach to do. So we find R naught, the position R naught, we find our tangent vector D, and then we can write it in this form.
Is that the parametric form that you're showing?
Yes, because that was what was asked. Find the parametric equations.
So in that form, could you take that out and make it x equals 1 minus pi root 3, y equals root 3 plus pi t, and z is equal to 1 plus 3t?
Yep.
So either version of the parametric equation would work. It's just, you just combine them.
Yeah.
Or like if you just left it in that second to last or third to last line, up 2 lines.
These three are all equivalent.
Okay,
The top one is the least useful one. Other than finding T naught. It's pretty easy at finding T naught because it's just the first vector. But if you're doing like finding the something at a later time, like say T naught is or T is 5, of course, our position is going to change too. This is just at T naught, which is 1/3. At a later time, we'd have a different position vector, so R naught would be different. This is only valid at that time. You guys ready to kick it up a notch? And we'll do integrals on Monday. We're going to work on 12.2 a little bit longer. Because we don't want to race through all of Calc 1 in just a single day, do we? That should be
After all, you
4
have to-
and 0.
after all, you have to enjoy it while it lasts.
Make sure everyone's pointing in the same direction. What do we actually need here?
first need CRDT.
We're going to need a DRDT. Why?
That's
I agree. Why?
Because we're finding a tangent line.
Because we're finding the tangent line. And since it's a line, we know the tangent line is going to have the form lines come in this flavor. but we need it at a specific t. V is basically r prime of t naught when we take the derivative. So we kind of need a t naught too, don't we? So we need the derivative. We need to figure out what t naught is. And we need to figure out what r naught is, but r naught should be pretty easy. Let me throw James in the bus. James, what's r naught?
What do you mean by R naught?
What is the position vector for at t equals 0?
410.
410. All right, good.
I thought it was that point evaluated.
We just turned that into a vector. That good. Keeping you on your toes. Can't let you ride your laurels. So how do I figure out t naught?
Whenever you plug into R to get E naught.
Yeah, what do I got to plug into r to get t naught?
It's kind of like. 2.
Looks like t equals, well, if I look at the t squared, it's showing me t equals plus or minus 2 on both the x component and the z component. Which one works for that component? Because it's not both. So I also need -1 over t plus 1 to equal 1. So -1 equals t plus 1, t equals -2. It's the -2 option. What's the form of the tangent line? What's dr dt looking like?
Like 2t.
That one's easy. That one's easy too. What's j hat?
Squared. I think it's 1 over t plus 1 squared, if I remember.
So if it sounds right, let's rewrite it and double check it. We got negative, and I can rewrite t plus 1 as to the -1 power. So we bring the power down, make it +1, and lower the power by 1.
Inside the.
The important thing is just to not accidentally find the integral instead. Like I was doing in my head.
You did, didn't you? You went for natural log, didn't you? I was wondering who.
I
was gonna-
did go for it. I have that horrible problem. Yeah, you have a question? How did we find T naught, you're saying?
Yeah, you just how you get.
You're working backwards. So in the original problem, we found P naught, we found R naught by integrating the T naught into the original equation. This time we had to work backwards by finding T naught by putting the making the R naught equal to the T's and finding a T that would work with that.
So one way of doing it, what he said, we're setting t squared equal to 4. We're setting 4 minus t squared equal to 0. We're setting -1 over t plus 1 equal to 1.
He essentially just kind of did a shortcut by saying like, oh, these can all both equal t plus or minus 2. What does this work for?
So in this case, x and z were not good options to choose. The square kind of gave me 2 answers. The y only had 1 possible answer though.
Because basically some t has to get to that point anyways. And you're saying.
Yeah, there's some t where it's happening at.
Because that point is.
If I can't plug in a t and get this point is not on that line. On that
Right, yeah.
curve. So I got T naught is -2.
And does it have to do with continuity, like why you chose that one or not really?
What do you mean?
I don't know.
Why, what do you mean chose? What do you mean chose?
Like that negative CO, because you said the other ones are like easy or whatever. Like, what do you mean by that?
Well, both +2 and -2 solve the X and Z, but only one of them solves the Y equation. -1 over T plus 1 has to equal 1.
Yeah, when you square root a number, you'll get plus or minus some.
Because if you put 2 in there, you'd get like a,
If I put a 2 in there, I'm getting -1/3,
oh yeah,
and I should be getting a 1.
never mind. I'm just thinking about holding it around.
And that's all good.
Last one.
Which is the V vector right now. I need to evaluate my derivative at T equals -2. So 2 times -2 is the X component.
So wait, how come we're just like, how do we get that 410? Like, how do we just turn that point into a vector? I don't get that part.
Because remember what R of T is doing is it's a position vector. R of T points to things from the origin. If the point P0 is 4, 1, 0, 1, 2, 3, 4, it's right here. The position vector to it is got to be that. If you want, you can treat this as P naught, where P is the origin.
Oh, I see. Okay. Fair enough. That makes
I
sense.
thought throwing an origin in might help.
Yeah.
So, so when we're doing these position vectors, any point from we can just write as a vector from the origin. Let's see, where was it? Okay, so I had 410 plus T times 2 times -2 is -4. Let's see, what is this bad boy when I stick in -2? I got -2 plus 1 is -1. -1 squared is 1. 1 over 1 is just 1, right? Gotta do that too quick. That gets me my 1. And then I've got -2 times -2. This -2 times our T was -2. That gives us +4. So our dr dt at T equals -2 is 4 minus 4T, 1 plus T, and 4T. Does that make sense?
That's the best form to put it in, like the most useful form. That last one.
I think so.
Is there any reason why you're using dr dt and r prime interchangeably?
There is. I'm
Switching a-
making sure. R prime is the easy way to it. But as soon as we start 12.3, and in particular, when we start doing chapter 13, we're not always taking the derivative with respect to time, because we're changing parameters in 12.3. We're not going to use time. And so I don't want everyone to get in the habit of just saying R prime, because in 12.3, we're going to have dr dt and we're going to have dr ds. And so just saying R prime is, well, which one are we doing? Which parameter are we using? S represents arc length. We're going to parameterize with our arc length
So then how
along the
come
curve.
you're writing it randomly? Like you're going in between both of them and during the equation. I'm just wondering like why.
I'm being lazy when I do the shortcut one. I'm trying to match the notation you see in the book on like things like that.
Right.
But everywhere else, I'm trying to get you used to doing DRDT or because we're going to be doing DRDS. And when we do partial derivatives, like when we are in 3 dimensions, if we only, like chapter 13, if I've got some function of R of X, Y, Z, and I only want to take a partial derivative with respect to X, we're doing DDX. And rather than, I can't just say R prime, because R prime is the total derivative.
Right.
And partial derivatives, we do this. The D changes to a funky D. And that's DDX, DDY partial derivative, DDZ partial derivatives. In fact, this is called, what is the name for that?
Oh, the gradient.
Oh, man. What do you think that?
It yields the gradient. This is something else.
Oh, is it a gradient? Well,
It's got some name. We'll get to it. But the point is, we're going to be doing different variables. And so I kind of want to start at least guiding you that way in the lecture. That way, when we start needing to do it, you're there. All right, it's 9 o'clock.
I'll be holding my SI hours tomorrow from 8:30 to 9:30 in Yoka 13 and 12 to 2 and card 712B for anybody that's interested.
Oh, if anyone wants Starbucks this weekend, let me know. Email or Discord me.
I'll be there.
It was a joke.
What day decided?
I'll see you there, Lawrence.
Saturday and Sunday.
Saturday and Sunday, 8 to 10.
So at the Starbucks, are they just gonna like go over? Or do one problem?
The Starbucks is pretty relaxed. Everyone kind of works at their own speed. If you've got, I'm there to answer questions. I'm basically like an on-site, ask me anything kind of thing.
Peace.
Okay. So, all throughout, oh gosh.